Jake Morrison sat in his small dorm room at Arizona State University reading the same message for the 10th time that day. The holographic screen showed an official letter from the Galactic Education Consortium, and Jake still could not believe what it said. He had been chosen for the first human exchange program at HFY University. Out of millions of students across known space, they had picked him. His roommate Danny walked into the room carrying books from his afternoon classes. Danny looked at Jake sitting on his bed with the glowing screen in front of him and shook his head. Danny had heard about this strange opportunity his friend had applied for months ago. Most people thought it was just another internet hoax, but Jake had filled out every form and submitted all the required documents anyway. Still reading. "That thing?" Danny asked while dropping his books on his desk. "You know this could all be fake, right? Nobody has ever seen aliens before, and now they suddenly want to trade students." Jake turned the screen toward his roommate so Danny could see the official seals and signatures that looked nothing like anything made on Earth. The letter came with detailed information about Zephyria Prime, including pictures of the university campus and data about the planet itself. The most shocking part was the temperature information. Average surface temperature was 160 degrees during cool periods and could reach over 180 degrees during peak heating cycles. "Look at these specs," Jake said, pointing to the environmental data. "This place makes Death Valley look like a vacation spot." No wonder they picked someone from Arizona. Danny leaned closer to read the details about the planet. Zephyria Prime orbited 2 stars, which meant it received massive amounts of heat and radiation. The planet had developed unique mineral formations and geological features that made it perfect for studying advanced engineering concepts. Universities from dozens of alien species sent their best students there to learn about extreme environment engineering. "And you actually want to go to this place?" Danny asked with disbelief in his voice. "Jake, this is insane. Look, it says here that all students must wear special climate control suits just to survive outside. These suits cost more than a car, and you still might die if something goes wrong." Jake stood up and walked to the window of their dorm room. Outside, he could see the Arizona desert stretching toward the mountains. He had grown up in Phoenix, where summer temperatures regularly hit 120 degrees. His family had always joked that Jake was part lizard because he seemed to love the heat, while everyone else ran for air conditioning. "That is exactly why this is perfect for me," Jake said, turning back to his roommate. "I have been dealing with extreme heat my whole life. My dad used to take me camping in the desert during summer, just to prove we could handle it. We would hike for hours in 115-degree weather with nothing but water and some shade cloth." Danny shook his head again, but Jake could see his friend was starting to understand. Jake had always been different when it came to heat tolerance. While other students complained about walking across campus during Arizona summers, Jake seemed comfortable even when temperatures soared. He had learned tricks from his father about staying cool without air conditioning and had always been fascinated by how the human body could adapt to difficult conditions. The acceptance letter included detailed instructions about what to bring and what would be provided. All students would receive advanced climate control suits that could maintain comfortable temperatures even in the most extreme conditions. These suits included air filtration systems, cooling units, and emergency backup power supplies. The university provided everything because student safety was their top priority. Jake read through the equipment list and frowned. The climate suit weighed over 40 pounds and required regular maintenance and charging. Students had to plan their daily activities around the suit limitations and could only spend limited time outside the climate-controlled buildings. The whole system seemed complicated and restrictive. "What if I did not use the suit?" Jake said. Suddenly, Danny looked at him like he had lost his mind. "What do you mean, not use the suit?" Danny asked. "Jake, the letter says clearly that the environment is deadly to most life forms. You would literally cook to death in minutes," but Jake was already thinking about alternatives. He had read survival stories about people living in extreme heat using simple techniques. Desert nomads had survived for thousands of years without any advanced technology. They used wet cloth for cooling, found shade during the hottest parts of the day, and understood how to work with their environment. Instead of fighting against it, Think about it, Jake said, getting excited about the idea. Humans evolved on a planet with huge temperature variations. We have deserts, Arctic regions, tropical jungles, and mountain peaks. Our bodies are designed to adapt to different conditions. Maybe these aliens never had to develop that kind of flexibility. Danny was quiet for a few minutes thinking about what Jake had said. It was true that Earth had much more diverse climates than most planets they had learned about in their xenobiology classes. Most alien species seemed to come from worlds with very stable environments where temperatures and conditions stayed the same year-round. But Jake, what if you were wrong? Danny asked with concern in his voice. What if human heat tolerance is not as good as you think? You could die on an alien planet billions of miles from home. Jake picked up the acceptance letter and read through it one more time. The opportunity was incredible. He would study advanced stellar engineering alongside alien species he had only seen in textbooks. The research facilities at Zephyria Prime were supposed to be the most advanced in the galaxy. Students who completed the program were guaranteed positions at top research institutions across known space. I have to try, Jake said finally. This is the chance of a lifetime. Besides, the worst that can happen is I get fitted for a climate suit if my natural methods do not work. The letter says they have backup equipment for emergencies over the next few weeks. Jake prepared for his departure by practicing heat endurance techniques. He spent hours in the Arizona sun during the hottest parts of the day testing different cooling methods. He experimented with wet bandanas, strategic shade, positioning and timing his activities to work with natural temperature cycles. His friends thought he was crazy, but Jake felt more confident each day that humans had natural advantages other species might not possess. The departure date arrived faster than Jake expected. At the spaceport, he met other exchange students from various alien species. Each of them carried massive cases filled with environmental equipment and backup life support systems. Jake carried only a simple duffel bag with clothes, some bandanas, and basic tools. A blue-skinned coordinator named Lisa approached Jake with obvious concern about his minimal luggage. She explained that Zephyria Prime was classified as extremely dangerous for most carbon-based life forms and asked if he had forgotten his environmental equipment. When Jake explained that he planned to try natural adaptation first, her large eyes showed shock and worry. The transport ship would provide normal atmospheric conditions during the journey, but once they arrived, Jake would be on his own. Lisa made him promise to stay in designated safe areas until proper equipment could be fitted and tested. Jake agreed, but privately planned to test his limits as soon as possible. As the ship prepared for departure, Jake looked out the window at Earth getting smaller in the distance. He was about to attempt something no human had ever tried before. Success would prove that humans were more adaptable than anyone realized. Failure could mean death on an alien world. But Jake had confidence in human evolution and the survival skills passed down through generations of desert dwellers. He was ready to show the galaxy what humans could really do. The transport ship touched down on Zephyria Prime just as the planet's two suns reached their peak position in the sky. Jake felt the heat immediately when the airlock opened, even though they were still inside the climate-controlled landing facility. The air itself seemed to press against him like a heavy blanket, and he could taste the dryness on his tongue. Around him, the other exchange students were already activating their climate control suits. Jake watched as each alien sealed themselves inside their protective equipment with soft mechanical sounds and quiet hums. The suits looked like small personal spacecraft with cooling vents, displays, and backup power units attached to the back and sides. Vex was a crystalline being from the Quillian system whose body looked like living gemstone. His climate suit resembled a mobile laboratory more than clothing, with multiple sensor arrays and temperature regulation systems. The suit completely enclosed his crystal form, and Jake could see cooling fluid flowing through transparent tubes built into the equipment. "Human Jake," Vex said through his suit's communication system. "Are you experiencing equipment malfunction? Your protective systems appear to be completely non-functional." Jake pulled a red bandana from his pocket and walked to a water fountain near the landing pad. He soaked the cloth thoroughly, then tied it around his neck. The cooling effect was immediate and noticeable as water began to evaporate against his skin. "No malfunction," Jake replied while adjusting the wet bandana. "Just testing how long I can go without the suit. Figured I would see what humans can handle naturally before relying on technology." A gaseous being named Nara drifted closer in her containment suit. Nara species existed as living gas clouds, so her environmental equipment was designed to hold her form together while providing life support. Her voice came from speakers built into the suit's chest panel. "This is fascinating," Nara said with genuine curiosity. "Your species can regulate internal temperature through liquid secretion. Our research indicated this was a primitive cooling method with limited effectiveness." Jake grinned and looked around the landing facility for shade and air movement. He could already feel sweat forming on his forehead, but it was not uncomfortable yet. The feeling reminded him of summer afternoons in Phoenix, when he would work outside with his father doing construction projects. "Primitive maybe, but it works," Jake said while studying the building's architecture. The alien designers had created many overhangs and recessed areas that provided natural shade. "Can I ask how long your suits can operate in this heat?" Cole was a scaled being from the Drakmari homeworld who looked like a humanoid dragon with intelligent yellow eyes. His climate suit was built for his larger frame and included extra cooling systems for his reptilian physiology. Cole checked the display on his suit's arm panel before responding. "Standard operation time is approximately 8 hours before requiring recharge or coolant replacement," Cole explained. "Extended physical activity reduces this time significantly. We must carefully plan our daily schedules around equipment limitations." Jake nodded and began walking toward the university's main buildings. He wanted to explore the campus and understand the environment before committing to any specific adaptation strategy. The other students remained clustered near climate-controlled areas, but Jake ventured farther into the heat to test his limits. The campus was designed with obvious consideration for the extreme environment. Buildings were connected by covered walkways, and every structure included multiple shade areas and protected spaces. Jake began mapping these features in his mind. While paying attention to airflow patterns and natural cooling zones. By his second day, Jake had established a basic routine. Early morning classes, when temperatures were only 120 degrees, felt almost comfortable compared to Arizona summers. He discovered that midday rest periods in carefully chosen shaded areas allowed him to recover from heat exposure while staying alert and functional. The real challenge came during afternoon laboratory sessions when temperatures peaked above 170 degrees. Jake found that understanding air movement was crucial for survival. He learned to position himself near ventilation systems and building features that created cross breezes. Moving air made the heat much more tolerable even without artificial cooling. His alien classmates watched with growing amazement as Jake not only survived but seemed to be adapting well to conditions that stressed their advanced life support systems. During lectures, Jake would sit comfortably in the back row, occasionally wiping sweat with a damp cloth but otherwise appearing unaffected by heat that kept everyone else sealed in protective equipment. Professor Zeth was an elderly Drakmari with decades of teaching experience and deep knowledge of stellar engineering. During a particularly challenging lecture on heat transfer principles, the professor finally addressed what everyone was thinking about. "Student Morrison," Professor Zeth said with his scaled head turning toward Jake, "your species' ability to function in these conditions without technological assistance is remarkable. Perhaps you would share your adaptation techniques with the class." Jake stood up, aware that every environmental suit sensor was focused on him. The classroom was completely silent except for the quiet hums of life support systems and cooling equipment. Jake could feel the curiosity and disbelief from his alien classmates. "Well, it is mostly about understanding the same heat transfer principles we are studying in class," Jake began. "Evaporation, convection, and radiation. My body is already designed for evaporative cooling through sweating. I just help it along with wet cloth and strategic positioning to catch air currents." He moved to the front of the classroom and picked up a piece of chalk. Jake began drawing simple diagrams showing how human thermoregulation worked and how he enhanced it with basic techniques. The key is working with the environment instead of fighting against it, Jake explained while sketching. Airflow patterns. Like right now, I am standing where the building's ventilation creates a natural convection current. My wet bandana increases surface area for evaporation, and I time my activities for when heat stress will be minimal. Vex's crystalline form shifted, colors indicating intense interest in what Jake was describing. But surely there are limits to this biological adaptation. What happens when temperatures exceed your natural tolerance? Jake smiled and continued his explanation. Definitely there are limits. I'm not invincible, and I have to be smart about exposure time and recovery periods. But humans evolved on a planet with huge climate diversity. We had to adapt to deserts, Arctic regions, jungles, and mountains. Our bodies are built for flexibility. The questions continued for the rest of the class period. Jake found himself explaining concepts he had learned from his father and grandfather about surviving in extreme heat. Desert survival techniques that had been passed down through generations suddenly seemed like advanced alien technology to beings who had never lived without climate control. Nara asked about hydration requirements, and Jake explained how humans could function with careful water management. Cole wanted to understand the relationship between activity levels and heat tolerance. Other students asked about mental effects and cognitive function during heat stress. The most important thing, Jake said as the class period ended, is understanding that heat adaptation is not just physical. You have to think differently about time and energy, work when conditions are best, rest when they are worst. Use your brain to make up for what your body cannot handle. After class, several students approached Jake with more questions. They were fascinated by the idea that biological systems could match or exceed technological solutions in specific environments. Some admitted that their species had never developed natural heat tolerance because their homeworlds had stable climates. Professor Zeth remained after the other students left. The elderly Drakmari looked at Jake with obvious respect and curiosity. Student Morrison, your success here challenges many assumptions about environmental adaptation, Professor Zeth said. I am beginning to think we may have underestimated human capabilities. Jake gathered his simple supplies and prepared to leave for his next class. Maybe the problem is that everyone assumes technology is always better than biology. Sometimes evolution already solved the problem millions of years ago. As Jake walked across campus in the blazing afternoon heat, he reflected on how much he had learned in just a few days. The environment was definitely more challenging than anything on Earth, but human adaptability was proving more effective than he had hoped. His success was not just personal achievement, but proof that his species possessed remarkable natural capabilities that other civilizations had lost or never developed. The real test would come soon when more extreme conditions pushed his adaptation techniques to their absolute limits. But for now, Jake was confident that humans belonged among the stars and could thrive in environments that challenged even the most advanced alien technology. 2 weeks into the semester, Professor Zeth made an announcement that would change everything for Jake and his alien classmates. The professor stood at the front of the advanced stellar geology classroom with a holographic display showing what looked like the surface of hell itself. Students, we have an important field expedition planned for next week, Professor Zeth said while the display showed a barren landscape of cracked earth and crystalline formations. We will be traveling to the scorched plains to collect samples from active thermal vents during peak solar heating. The announcement caused immediate concern among the students. Jake could hear nervous conversations through the communication systems of various climate suits. The scorched plains were legendary, even among the heat-adapted species, for being one of the most hostile environments on any inhabited planet. Cole raised a clawed hand from inside his environmental suit. Professor, our climate suits are rated for extended operation, but 4 hours in those conditions will push our systems to maximum limits. Some older equipment might not be able to handle the stress. I understand your concerns, Professor Zeth replied while changing the display to show temperature readings and environmental data. Surface temperatures at the thermal vents regularly exceed 180 degrees with some areas reaching over 200 degrees. The expedition will require 4 hours of fieldwork during maximum solar exposure. Jake studied the holographic images with growing excitement rather than fear. The scorched plains looked like an alien moonscape crossed with a volcanic region. Heat distortion made the horizon shimmer and bend like looking through water. Crystalline formations jutted up from cracked ground that looked baked and lifeless. This is why we have arranged for mobile cooling stations and emergency backup equipment, Professor Zeth continued. However, I must stress that this environment represents the upper threshold of survivability, even with our most advanced life support technology. Vex's crystalline form shifted to orange, indicating stress and concern. Professor, what safety protocols will be in place if equipment fails? The thermal conditions could cause permanent damage to biological systems within minutes. Excellent question, Professor Zeth said. All students will work in pairs with backup cooling units and emergency transport. Standing by. Medical teams will monitor everyone constantly, and any sign of heat stress will result in immediate evacuation. Jake raised his hand and the professor nodded for him to speak. Professor, what if someone wanted to attempt the expedition without a climate suit? The classroom fell completely silent. Even the quiet hums of life support systems seemed to pause as every being processed what Jake had just suggested. Several students turned their sensors toward him as if checking whether he was experiencing some kind of mental breakdown. Student Morrison, Professor Zeth said slowly, I must strongly advise against such an attempt. The environmental conditions exceed safe parameters for unprotected organic life by enormous margins. University policy requires that I cannot authorize such a dangerous experiment. But Jake was already thinking through the possibilities. He had been testing his heat tolerance every day and felt confident about his natural adaptation abilities. The scorched plains would be the ultimate test of human environmental flexibility. What if I volunteered for a separate supervised trial? Jake asked. Maybe prove the concept on a smaller scale first before the main expedition. The interest in the room was obvious even through environmental suits. Nara's gaseous form swirled more rapidly within her containment system, indicating excitement. You would actually risk such extreme exposure for academic research purposes, not risk, Jake corrected. Calculate and prepare. Humans have survived in extreme heat before without any technology. Death Valley, the Sahara Desert, Australian outback. This is definitely hotter, but the basic principles should be the same. Several students began talking at once through their communication systems. Jake could hear fragments of conversations about human biology, thermal limits, and survival capabilities. Some seemed fascinated, while others sounded concerned about his mental state. Professor Zeth raised a scaled hand for silence. Very well. Student Morrison, we will conduct a preliminary test tomorrow. 1 hour of controlled exposure with full medical monitoring and emergency support. If you can demonstrate safe operation, we will discuss participation in the main expedition. That evening, Jake worked late in his dormitory room, planning his survival strategy with scientific precision. His alien roommates Zix, a quiet Quillian, and Finn, an enthusiastic Altarian, watched with fascination as he sketched designs and calculated heat load factors. You realize, Zix said with his crystalline voice making musical tones, that your biological cooling system is being studied by xenobiologists across the galaxy. Most species consider effective biological thermoregulation to be essentially impossible. Jake looked up from his notebook where he was drawing plans for a portable shade structure. What do you mean impossible? Finn's blue skin darkened with embarrassment. As he explained, we honestly assumed it was exaggerated in human cultural materials. The idea that biological entities could survive extreme heat through liquid secretion seemed too simple to actually work effectively. Sometimes the simple solution is the best solution, Jake replied while returning to his calculations. Complex systems have more parts that can break. Biology has been solving the heat problem for millions of years. Jake was designing more than just basic survival equipment. His portable shade structure would use lightweight reflective materials to create a cool zone while allowing air circulation. He planned an evaporative cooling system using the local mineral water that would provide multiple cooling surfaces. But what if the conditions are beyond even human capabilities? Zix asked with genuine concern. Your species may be adaptable, but these temperatures approach the limits of organic survival. Jake considered the question seriously. He had been pushing his heat tolerance every day since arriving on Zephyria Prime and felt confident about his natural limits. But the scorched plains would be different from anything he had experienced. Then I learned something important about human limitations, Jake said. But I do not think we will reach those limits. Humans are tougher than most people realize, including humans themselves. The next morning, Jake prepared for his test with the same careful attention he would give to any important engineering project. He selected lightweight clothing that would allow maximum air circulation while protecting his skin from direct radiation. His cooling supplies included several bandanas, mineral water, and materials for his shade structure, medical technician. Aura was a spider-like arachnoid whose multiple sensor arrays could monitor biological functions with incredible precision. She calibrated her equipment while expressing obvious concern about the upcoming test. Human Jake, I will be tracking your core temperature, hydration levels, neural activity, and cellular stress throughout the trial, Aura explained. Any indication of dangerous deviation and the test ends immediately regardless of your personal preferences. Understood. Completely, Jake replied while checking his equipment one final time. Safety first, but I want to show what humans can really do. Professor Zeth and a group of students gathered at the edge of the designated test area as temperatures climbed toward 175 degrees. Jake could feel their curiosity and concern through their environmental suits. This test would either prove human adaptability or demonstrate the limits of biological survival. Jake pulled his shade structure from his backpack and began assembly with practiced efficiency. The design was simple but effective, using reflection and air movement to create a survivable microenvironment. Within minutes, he had created a cool zone that was noticeably more comfortable than the surrounding area. Ingenious, Vex commented, while his crystalline sensors analyzed the light reflection patterns. The human is using solar energy redirection rather than energy-intensive mechanical cooling. Jake's water system came next. He had brought several containers of mineral water, which he used to create an evaporative cooling network. Wet cloths hung from the shelter frame created multiple surfaces for evaporation. A shallow pan positioned to catch the prevailing wind added additional cooling through enhanced air circulation. Core temperature stable, Aura announced from her monitoring station. Hydration levels declining as expected but remaining within acceptable parameters. The real test began when Jake ventured outside his shelter to collect sample materials similar to what would be required during the actual expedition. He moved with careful efficiency, working in short bursts before returning to his cooling zone. His technique involved constant motion to generate air circulation, frequent water application to cooling points, and strategic use of any available shade. Remarkable, Professor Zeth observed as Jake completed his third sample collection run. The human is maintaining operational effectiveness in conditions that would overwhelm most climate control systems. 30 minutes into the test, Jake decided to demonstrate his most ambitious technique. He had identified a small thermal vent similar to those at the expedition site and wanted to show how he could work directly around intense heat sources. This is where understanding heat transfer really becomes important, Jake explained as he approached the vent, which was radiating visible heat waves. News of Jake's successful heat adaptation test spread through Zephyria Prime University faster than a solar flare racing across the planet's surface. Within hours of completing his demonstration, xenobiology departments from dozens of worlds were requesting detailed studies of human thermoregulation capabilities. The planned expedition to the Scorched Plains became the most anticipated academic event of the entire semester. Professor Zeth called Jake to his office the morning after the test to discuss the implications of what had been accomplished. The elderly Drakmari professor sat behind a desk covered with research papers and data displays showing temperature readings from the previous day. Student Morrison, your success yesterday has created quite a stir among the faculty, Professor Zeth said while reviewing the medical data. Technician Aura's readings show that you maintained stable biological function in conditions that would require emergency evacuation for most species even with full life support. Jake sat comfortably in the office chair feeling proud but also aware of the responsibility his success had created. I am glad the test went well, Professor. Does this mean I can participate in the main expedition? More than participate, Professor Zeth replied with obvious excitement. We want you to lead the primary sample collection using your biological adaptation methods while the rest of the team provides support from climate-controlled stations. Your techniques could revolutionize how we approach extreme environment. Research. The expedition was scheduled for the following week when Zephyria Prime's dual suns would be in optimal position for studying the thermal vent formations. Jake spent the intervening days refining his equipment and testing new cooling techniques based on lessons learned from his trial. His improved shade structure incorporated multiple layers of reflective material that could be adjusted based on sun angle and wind direction. The evaporative cooling system was expanded with additional water containers and more efficient cloth placement for maximum surface area exposure. Jake even developed backup plans for different wind conditions and emergency procedures if his primary equipment failed. The expedition team assembled at dawn on what promised to be one of the hottest days of the local season. Jake's alien classmates were sealed inside their most advanced climate suits with backup cooling units and emergency power supplies. He wore lightweight clothing and carried his cooling equipment in a simple backpack expedition. Leader Mex was a stocky Drakmari whose environmental suit included extra cooling systems and extended operation capabilities. All personnel will remain within designated climate-controlled zones except for approved collection activities, Mex announced. Student Morrison will conduct primary fieldwork while we monitor from protected positions. The journey to the scorched plains took 2 hours in a specially equipped transport vehicle. Jake watched through the windows as the landscape became increasingly barren and hostile. Heat distortion made distant objects shimmer and dance like mirages. Crystalline formations jutted from cracked earth that looked baked and lifeless. Incredible, Nara said through her containment suit's communication system. How can any environment naturally reach such extreme temperatures? Binary star system, Jake replied while studying the terrain features. 2 suns means double the radiation input. Plus, the mineral composition probably stores and reflects heat very efficiently when they reach the expedition site. Jake immediately understood why this place was legendary for its hostility. The scorched plains stretched to the horizon like an alien moonscape crossed with a volcanic field. Steam rose from thermal vents that glowed with internal heat. The air itself seemed to shimmer with visible energy. Establishing base camp, Mex announced while deploying climate-controlled shelters and monitoring equipment. Surface temperature currently 185 degrees and rising. Student Morrison, you may begin setup whenever ready. Jake assembled his advanced cooling station with the efficiency of someone who had practiced every step dozens of times. The improved design created multiple shade zones with strategic positioning to capture available air movement. His evaporative cooling system included backup water supplies and redundant cloth placement for maximum effectiveness. Beginning collection sequence, Jake announced while checking his hydration levels and adjusting his cooling cloths. The watching students and faculty represented 12 different species, all protected by environmental suits, all amazed that a biological entity was about to venture unprotected into conditions hot enough to damage their technology. The first thermal vent proved to be Jake's biggest challenge yet. Surface temperatures near the vent exceeded 200 degrees and the radiant heat was intense enough to be felt through his shade structures. But Jake had anticipated this, bringing reflective shields and developing techniques for working in short, efficient bursts. Sample collection alpha complete, Jake reported after 10 minutes of work around the hottest vent. His shirt was completely soaked with perspiration and sweat ran freely down his face, but his movements remained steady and controlled. Core temperature readings showed elevation, but within safe parameters. Vex's crystalline form, shifted to deep blue, indicating amazement at what he was witnessing. The human's biological systems are maintaining function, despite proximity to thermal sources that would overwhelm our mechanical cooling. Technology. Jake's technique involved careful timing and strategic positioning. He would approach each vent during brief periods when air circulation was optimal, then retreat to his cooling station for recovery and rehydration. Each collection run was planned to minimize heat exposure while maintaining the precision required for scientific work. Sample collection beta complete, Jake announced after successfully gathering materials from the second thermal vent. The work was exhausting, and he had consumed nearly 2 liters of water, but his natural cooling systems were functioning exactly as designed. By millions of years of evolution, the expedition continued for 4 hours, with Jake successfully collecting samples from 12 different thermal vents while his classmates monitored from their climate-controlled shelter. His success was not just about survival, but about maintaining the careful attention and steady hands required for precise scientific work under extreme stress. Final sample secured, Jake reported while sealing the last collection container. He was exhausted and had consumed nearly 6 liters of water throughout the day, but he had completed every required task without any equipment failures or emergency interventions. Medical technician Aura approached with her monitoring equipment showing obvious amazement at the readings. Human Jake, your biological performance during this expedition exceeds all theoretical predictions about organic heat tolerance. Your core temperature never exceeded safe parameters despite working in conditions that challenge our best technology. The return journey to the university became an impromptu celebration of human achievement. Jake's success had implications far beyond academic research. He had demonstrated that biological adaptation could match or exceed technological solutions in specific environmental conditions. Back at the university, the response was unprecedented. Dean Corax was an ancient Altarian who rarely left her climate-controlled administrative complex. She personally met the expedition team upon their return to congratulate Jake on his remarkable achievement. "Student Morrison," Dean Corax said, with her melodic voice carrying formal tones of respect, "your success today has caused us to fundamentally reevaluate our understanding of biological adaptation capabilities. We would like to offer you a unique position." Jake, finally cool and fully rehydrated, looked curious about this unexpected opportunity. "What kind of position, Dean Corax?" "We want you to develop and teach a new course called Biological Adaptation and Environmental Survival," the dean explained. "Species from across the galaxy are requesting access to human survival techniques. Your methods could save lives and advance our understanding of natural adaptation." The offer was extraordinary. Jake would become the first human to hold a permanent teaching position at a galactic university. His course would attract students from dozens of worlds who wanted to understand how humans had developed such remarkable environmental flexibility. "I accept," Jake said without hesitation. "But I want to make sure the course focuses on practical techniques that can actually help people survive in dangerous conditions." Within days of Jake's expedition's success, the university began receiving applications from students representing 47 different worlds. Everyone wanted to learn about human survival methods and understand how biological systems could compete with advanced technology. Jake's first class attracted beings from species that had never considered the possibility of surviving without environmental suits. His curriculum covered everything from basic thermoregulation to advanced environmental adaptation, all based on techniques that humans had developed naturally over millions of years. The key principle, Jake explained to his diverse class, is understanding that technology should enhance natural capabilities, not replace them completely. Humans survived in extreme environments for thousands of years before developing climate control. Though survival instincts and techniques are still valid and often more reliable than complex equipment. The course became legendary throughout the galactic education community. 1 year after Jake Morrison first stepped onto the scorching surface of Zephyria Prime, his name had become legendary throughout the galactic education community. The human who survived extreme heat using wet cloth and basic engineering principles, was now Professor Morrison, teaching the most popular course in the university's history. The classroom where Jake held his biological adaptation and environmental survival course had been expanded 3 times to accommodate students from across known space. Beings who had never questioned their dependence on technology now eagerly learned techniques that humans had developed through millions of years of natural evolution. Today we are going to discuss emergency adaptation when your technology fails, Jake announced to his packed classroom. Students representing dozens of species sat in environmental suits designed for learning rather than survival. Many had modified their equipment based on principles learned in previous classes. Zara was a young Quillian whose crystalline form shifted through various colors as she processed information. Professor Morrison, what should we do if our climate control systems fail completely during an emergency situation? Jake smiled and moved to the demonstration area where he had set up various survival scenarios. Excellent question, Zara. The first rule is do not panic. Technology fails, but biological adaptation works if you understand the principles. He picked up a simple cloth and soaked it in water from a container on his desk. Emergency cooling can be achieved with any absorbent material and any available liquid. The key is maximizing surface area for evaporation while protecting vital cooling points on your body. The demonstration that followed showed techniques Jake had refined over months of teaching. He showed how to create emergency shade using reflective materials, how to position oneself to catch air currents, and how to recognize the early signs of heat stress before they became dangerous. Cole raised a scaled hand from his position in the middle of the classroom. Professor, these techniques require no power sources or complex equipment. Why did our species never develop similar methods? That is one of the most important questions in this course, Jake replied while setting up his next demonstration. Most species evolved on worlds with stable climates where adaptation was not necessary for survival. Humans came from a planet with extreme diversity where flexibility meant the difference between life and death. Jake's teaching methods had revolutionized how the university approached environmental training. Instead of relying entirely on technology, he showed students how to work with their natural capabilities enhanced by simple tools and techniques. The success of his program had attracted attention from the highest levels of galactic government. Admiral Chen was the human representative to the Galactic Council and had traveled to Zafia Prime specifically to meet with Jake about expanding his training methods. Professor Morrison, Admiral Chen said during their meeting in the university's administrative complex, your work here has implications far beyond academic education. Military and exploration commands across the galaxy are requesting access to human survival training. Jake looked out the window of the meeting room at students practicing outdoor adaptation techniques in the blazing afternoon heat. Beings who had arrived completely dependent on environmental suits were now learning to function with minimal technology. I am honored by the interest, Admiral, but I want to make sure we maintain focus on education rather than military applications, Jake replied. These techniques should be used to save lives and advance understanding, not to create advantages in conflict. Agreed completely, Admiral Chun said. But consider the exploration benefits. Colony ships equipped with survival-trained crews could establish settlements in environments previously considered impossible. Research teams could work in conditions that would overwhelm traditional life. Support systems. The conversation continued for hours as they discussed the broader implications of Jake's success. His demonstration that biological adaptation could compete with advanced technology had changed fundamental assumptions about what was possible for organic life forms. Meanwhile, Jake's students were making remarkable progress in their own adaptation. Training, species that had never experienced natural temperature regulation were learning to function in conditions that would have required full environmental suits. Just months earlier, Finn was an Altarian whose blue skin had adapted to show heat stress indicators that helped him regulate his exposure. Professor Morrison, I successfully completed a 2-hour session yesterday at 150 degrees Using only cloth cooling and shade positioning, outstanding progress, Finn, Jake replied with genuine pride. Remember that adaptation is a gradual process. Do not push beyond your natural limits too quickly. The success stories continued throughout the semester. Nara had developed techniques for managing her gaseous form in extreme heat without full containment systems. Vex had learned to modify his crystalline structure to reflect heat more efficiently. Each species found ways to enhance their natural capabilities, using principles learned from human survival methods. Jake's research had also attracted the attention of evolutionary biologists who wanted to understand why humans had developed such remarkable environmental flexibility. Dr. Wells was a human xenobiologist who had joined the university faculty specifically to study biological adaptation. Jake, your success here suggests that Earth environments were far more challenging than we previously understood, Dr. Wells said during one of their research sessions. Human heat tolerance exceeds what should be possible based on our planet's recorded climate data. Maybe the data does not tell the whole story, Jake replied while reviewing temperature logs from his latest fieldwork. Humans spread across every climate zone on Earth. Desert nomads, Arctic hunters, tropical farmers, mountain climbers. We had to adapt to everything or die. Their research revealed that human biological flexibility was the result of surviving on a planet with extreme environmental diversity. Unlike most alien species who evolved in stable conditions, humans had developed remarkable adaptability as a core survival trait. The implications extended far beyond heat tolerance. Human students began arriving at Zephyria Prime to study other forms of environmental adaptation: cold tolerance, pressure adaptation, low oxygen survival, and radiation resistance became new areas of investigation. Jake found himself at the center of a revolution in thinking about biological capabilities versus technological dependence. His success had proven that evolution sometimes provided better solutions than engineering. The most important lesson, Jake told his students during the final class of the semester, is that biology and technology should work together, not replace each other. Understand your natural capabilities, then enhance them with tools and techniques. The graduation ceremony for Jake's first full class was attended by representatives from universities across the galaxy. Students who had arrived completely dependent on environmental suits were now qualified as emergency survival instructors for their own species. Dean Korax addressed the assembled graduates with obvious pride in their achievement. You represent the first generation of beings trained in biological adaptation techniques. Your knowledge could save countless lives during emergencies and expand the boundaries of what we consider possible. Jake watched his students receive their certifications with satisfaction that went beyond personal achievement. He had proven that humans belonged among the stars, not just as another species with advanced technology, but as beings with unique natural capabilities that made them invaluable to galactic civilization. The long-term impact of Jake's work would be measured in decades and centuries. Exploration missions equipped with adaptation-trained crews would establish colonies in previously impossible environments. Emergency response teams would save lives using techniques that required no power sources or complex equipment. His story had become legend, but more importantly, it had changed how the galaxy viewed both human potential and the relationship between biology and technology. Jake Morrison had shown that sometimes the best engineering was the kind that evolution had already perfected. Years later, when other humans joined galactic universities and research institutions, they found doors opened by Jake's pioneering work. His success had established humanity as a species with remarkable natural capabilities rather than just another civilization dependent on technology for survival. The human who conquered Zephyria Prime with wet cloth and shade engineering had proven that Earth's greatest export was not advanced machines or sophisticated science, but the biological adaptability that allowed humans to thrive anywhere in the universe. That lesson would resonate throughout galactic civilization for generations to come as humanity took its place among the stars, not as followers but as teachers of survival and adaptation in the most challenging environments the universe could provide. Jake's legacy lived on in every emergency protocol that incorporated biological adaptation techniques and every exploration mission that succeeded in impossible conditions using methods learned from human survival instincts. He had shown the galaxy that sometimes the most advanced technology was the one that nature had already invented.